Hello students, let us start with matrix representation of system of linear equations. Matrix representation of system of linear equations. An arbitrary non-homogeneous system. In previous video we have discussed what is non-homogeneous system of m linear equations in n unknowns is written as a11 x1 plus a12 x2 plus and so on, a1n xn is equals to 0. a21 x1 plus a22 x2 plus and so on plus a2n xn is equal to 0, and so on up to am1 x1 plus am2 x2 plus and so on amn is equals to bn, where not all bi's are 0, because this is a system of non-homogeneous system of linear equation. Okay, and similarly an arbitrary homogeneous system of m linear equations in n unknowns is written as a11 x1 plus a12 x2 plus and so on a1n x1 xn is equals to 0. a21 x1 plus a22 x2 plus and so on plus a2n xn is equals to 0, and so on up to am1 x1 plus am2 x2 plus and so on amn xn is equals to 0. This is a homogeneous system of m linear equations in n unknowns, because all bi's are here 0. Suppose call this equation number 2 and this is equation number 1. Okay, now using equality of matrices, the system 1 can be written as matrix a11 x1 plus and so on up to a1n xn and so on up to am1 x1 plus and so on up to amn xn is equals to matrix p1 and so on up to bn, where left hand side column matrix the expressions are single entry. Further, using matrices multiplication of matrices, we write above equality as matrix A11, A12 and so on up to A1n, A21, A22 and so on up to A2n. This is up to AM1, AM2 and so on up to AMN. Okay, into matrix x1, x2 and so on up to xn. This is equals to matrix B1 and so on up to Bm. Okay. Further, this can be written as this can be written as A into X is equals to B, where A matrix is A11, A12 and so on up to A1n, A21, A22 and so on up to A2n. This is up to AM1, this is up to AM2 and so on up to AMN. Okay, which is called the matrix of coefficients of the system, which is called coefficient of the system 1. And X is equals to matrix x1, x2 and so on up to xn, and B is equals to matrix b1, b2 and so on up to bm are column matrices of unknowns and right hand side constants of the system respectively. This is column matrix of unknowns and this is column matrix of right hand side constant of the system. Okay, suppose this is equation 3. The matrix equation 3 is called the matrix representation of the non-homogeneous system of linear equation. Okay, system of linear equation. Similarly, the homogeneous system of linear equation given in 2 can be written in matrix form as written in matrix form as Ax is equals to 0. Call this equation number 4, where A is the coefficient matrix and X is column matrix of unknowns and 0 is the matrix of zeros of order m by 1. Okay. Now let us take one definition. Definition is: given a non-homogeneous system of linear equations, given a non-homogeneous system of linear equations, one, the block matrix A augmented B, this is equals to A11, A12 and so on up to A1n, A21, A22 and so on up to A2n. This is up to AM1, AM2 and so on up to AMN. This is up to AMN. Here B1, B2 and so on up to Bn. Bn is called augmented matrix of the given system. This matrix is called augmented matrix of given system. Called augmented matrix of given system. Okay. Let us take example. Write down the following system in matrix form. Write down the following system. Write down the following system in matrix form. System is 2x1 plus 2x2 plus 2x3 is equals to 0, minus 2x1 plus 5x2 plus 2x3 is equals to 1, 8x1 plus x2 plus 4x3 is equals to minus 1. As previous we have seen, matrix form of a non-homogeneous system is A into X is equals to B. Okay, where A is the coefficient matrix of the system. Solution: the matrix representation of the system is A into X is equals to B, where A is equals to matrix. First column is the coefficient of x1, second column is the coefficient of x2, and third column is the coefficient of x3. So 2, 2, 2, minus 2, 5, 2, 8, 1, 4. Okay, where x is equals to x1, x2, x3, and b is equals to, b is nothing but the right hand constants of the system. These are 0, 1, minus 1. Okay, the augmented matrix for this system is equals to, first write down A, 2, 5, 2, 8, 1, 6, 4, draw a line and then write down B, 0, 1, minus 1. This is the augmented matrix for the given system. Next example, write down the corresponding system of linear equations for the given augmented matrix. Matrix 0, 0, minus 2, 0, 7, 2, 4, minus 10, 6, 12, 2, 4, minus 5, 6, minus 5, 12, 18, and minus 1. The system of linear equation is the system of linear equation is, this is matrix A and this is matrix C. This is the coefficient matrix of the system and this is right hand side constants of the system. Okay, in first row x1 coefficient of x1 is 0, coefficient of x2 is 0, so this is only minus 2x3 plus 7 x5 because coefficient of x4 is 0, which is equals to 12. Second equation is 2x1 plus 4x2 minus 10x3 plus 6x4 plus 12x5 is equals to 8. And last is 2x1 plus 4x2 minus 5x3 plus 6x4 minus 5x5 is equals to minus 1. This is the system of linear equation of given augmented matrix. Okay. Now let us see next topic, Gauss elimination and Gauss-Jordan elimination method. Gauss elimination and Gauss-Jordan elimination method. Gauss elimination and Gauss-Jordan elimination method. Okay. Definition: given a system of linear equations, given a system of linear equations, if we reduce the augmented matrix, of this system to row echelon for, then write the corresponding system, and solve it. Then write the corresponding system and solve it by back substitution. Solve it by back substitution. This method of solving the given system is system of linear equation is known as Gauss elimination method. Is known as Gauss elimination method. If the augmented matrix is reduced to row echelon form, then write the corresponding system. Write the corresponding system of linear equation. And solve it. This method of solving a system of linear equation is known as Gauss-Jordan method. Gauss-Jordan elimination method. Given a system of linear equation, if we reduce the augmented matrix of this system to row echelon form, then we write the corresponding system and solve it by back substitution. This method of solving the given system of linear equation is known as Gauss elimination method. And if the augmented matrix is reduced to row echelon form, then write the corresponding system of linear equation, solve it. This method of solving system of linear equation is known as Gauss-Jordan elimination method. Okay. For better understanding of these methods, we will see one example. Consider the augmented matrix. Example is consider the system of linear equation. X1 plus 2x3 plus x4 is equals to 5. X1 plus x2 plus 5x3 plus 2x4 is equals to 7. X1 plus 2x2 plus 8x3 plus 4x4 is equals to 12. Okay. This is system of linear equation which we have given. Now we have to find solution. consider the augmented matrix. Consider the augmented matrix. Consider the augmented matrix of this system. Consider the augmented matrix of this system and apply operation. Okay, we have A augmented, B means augmented matrix of this system is, first write down matrix A. 1 coefficient of x2 is 0 here, so this is 1 0 2 1 1 1 5 2 1 2 8 4 5 7 12. This is augmented matrix for the given system. Okay, now this one is the leading one for this first row. Okay, so we have to obtain row echelon form and reduced row echelon form, in which we require here and here 0. For that we will perform a row operation R2 plus minus 1 into R1 and R3 plus minus 1 into R2. So matrix will become 1 0 2 1 5 R2 minus R1. 1 minus 1 is 0. 1 minus 0 is 1. 5 minus 2 is 3. 2 minus 1 is 1. 7 minus 5 is 2. Okay. Again, for third row, R3 minus R2 means what? 1 minus 1 is 0. 2 minus 0 is 0. 8 minus 2 is 6. 4 minus 1 is 3. 12 minus 5 is 7. Okay. For second row, this one is leading one. So here we require 0. For that, we will perform a row operation. I will write down here. I will perform a row operation R3 minus 2 into R2. So our matrix will become 1 0 2 1 5 0 1 3 1 2 0. 2 minus 2 is 0. 6 minus 6 is 0. 3 minus 2 is 1. 7 minus 4 is 3. Okay. Suppose call this equation. Suppose call this matrix as star. Okay. This is row echelon form of this augmented matrix. Obtain reduced row echelon form. For this, see here, for this column is only this one is the non-zero entry in this column. Again, this one is the leading one in this column. Here, this one is the leading one for this column. So here we require 0 0. For this purpose, we will perform a row operation R2 minus R3, R1 minus R3. Okay. So this matrix will become, this is as it is, 1 0 2. Here 1 minus 1 is 0. R1 minus R3. So here 5 minus 3 is 2. 0 1 3. 1 minus 1 is 0. 3 minus 2. Our operation is R2 minus R3. 2 minus 3 is minus 1. And third row as it. Okay. This is reduced row echelon form of augmented matrix. Why this form is a reduced row echelon form? Because each column that contains the leading one has zeros everywhere. See here, this column contains leading one which has a zeros everywhere. Also this column contains a leading one has zeros everywhere, and also this column contains a leading one has zeros everywhere. Okay. Suppose call this double star. This matrix is double star. Now see here, for Gauss elimination we write down the system of equation corresponding to row echelon form star. For Gauss elimination we write down the system of equations corresponding to the row echelon form star. Okay. Then we get x1 plus 2x2 plus 2x3, coefficient of x2 is 0, plus x4 is equals to 5. x2 plus 3x3 plus 1x4 is equals to 2, and last is x4 is equals to 3. Okay. Here x4 is equals to 3. Students, see here, column third has no leading one, therefore x3 is a free variable. Okay. From that we will get here x4 is equals to 3. Suppose this is 1, this is 2, and this is 3 equation. So implies x2 is equals to minus 3x3 minus x4, which is equals to minus 3x3 minus x4 is minus 3. So we will get x2 is equals to here is plus 2 plus 2. So we will get minus 3x3 minus 1. This is the value of x2. Here I will write here only x2 is equals to minus 1 minus 3x3. Okay. Now similarly we can find x1 from equation 1. x1 implies x1 not implies x1 is equals to minus 2x3 minus x4 plus 5, which is equals to minus 2x3 minus x4 is minus 3 plus 5. This is nothing but minus 2x3 plus 2. This is your x1. So write here this x1. x1 is 2 minus 2x3. Okay. See here, this x3 is a free variable, so we assign any value to this x3. Suppose put x3 is equals to t. Then what we get? We get the solution. Therefore, the solution set of the system is given. Solution set of system is x1 is equals to 2 minus 2t, because x3 is equals to t. x2 is equals to what? Minus 1 minus 3t. x3 is equals to t and x4 is equals to 3. T belongs to R. So here I will write what? This is the solution set for the system, or we can write S is equals to x1 is 2 minus 2t, x2 is minus 1 minus 3t, x3 is t and x4 is 3. Okay, such that t is belongs to R. Such that t is belongs to R, or this can be written as, or this can be written as 2 minus 1 comma 0 comma 3 plus t into, write down the coefficient of t, minus 2 minus 3 1 0, such that t is belongs to R. Okay, students, always remember that when we have to find the solution of system of linear equation by using Gauss elimination method, for that write down the augmented matrix of the system, then obtain row echelon form it. In next step, write down the system of equations corresponding to row echelon form, solve it and find out the values of variables. Okay, now we have to find the solution of this system by using Gauss-Jordan elimination method. For Gauss-Jordan elimination method, we use reduced row echelon form of given augmented matrix. For this is our row reduced form of augmented matrix AB. Okay, for Gauss-Jordan elimination method, for Gauss-Jordan elimination method, for Gauss-Jordan elimination method, we write down the system. We write down the system. We write down the system of equations corresponding to the reduced row echelon form for double star. Then we get x1 plus 2, x3 is equals to 2, x2 plus 3, x3 is equals to minus 1, and last is x4 is equals to 3. Here x2 plus 3x3 is equals to minus 1, x4 is equals to it is straightforward. This augmented matrix is 1 0 2 0 2. Okay, x4 is equals to, that implies x1 is equals to 2 minus 2x3, x2 is equals to minus 1 minus 3x3, and x4 is equals to 3. Okay, again here x3 is a free variable. Put x3 is equals to T. Therefore solution set S is x1 is equals to 2 minus 2t, x2 is equals to minus 1 minus 3t, and x3 is equals to t, and x4 is equals to 3. T belongs to R. Therefore S is equals to 2 minus 2t, comma, minus 1 minus 3t, comma, t, 3, such that T is belongs to R. Okay. This is equals to 2 comma minus 1 comma 0 comma 3 plus T into minus 2 comma minus 3 comma 1 0, such that T belongs to R. Okay. Okay, we will stop here. Sorry. Before that, and keep in mind that if you we have to solve the system of linear equation by using Gauss-Jordan elimination method. For that, first of all, we have to write down augmented matrix of that system, then reduce it to reduced row echelon form, and write down the system of equation corresponding to reduced row echelon form. Solve it. Okay. Okay, we will stop here. Thank you.